Hi, Patrick. I figured the best way to answer this question would be to make you a quick video. So on number 6, it says an 8 meter ladder is leaning against a vertical wall. If a person pulls the base of the ladder away from the wall at a rate, so that is really important, a rate of a half a meter per second, how fast is the top of the wall moving down top of the ladder moving down the wall when the base of the ladder is 3 meters from the wall? So the reason that we know to do derivative here is because they're talking about rates. They're telling us how fast x is changing, and they're asking us to figure out how fast y is changing. So when a ladder leans against a wall, it creates a right triangle. So this can be our wall here. And then this is the ground. And we've got this ladder that just leans against the wall. So we're going to assume, and it's safe to assume that that's going to form a right triangle. The ladder, which is this side here, we're told is 8 meters long. And the length of that ladder is never going to change. So anytime we refer to that side of the triangle, we can always just use 8. We don't ever have to use a variable there. But somebody is pulling this ladder away from the wall down here at the bottom. And when that happens, the top of the ladder is going to fall because we've got to maintain this right triangle with a hypotenuse of 8. So if the length of one side increases, the length of our other side is going to decrease. Since we have a right triangle here, that tells me that we've got to start with our Pythagorean equation, because we're talking about the lengths of the 3 sides of a right triangle. So x squared plus y squared equals 8 squared. I'm going to say that x is the ground and the y is the wall. So the other information we're given, it says the ladder is pulled away from the wall at a rate. So anytime we have a rate, it means a derivative. And since the ladder is being pulled away horizontally, that's telling us the rate at which x is changing. And if we think of this point as being 0, 0, when we pull that ladder away, what we're doing is we are lengthening that side. So it's positive 0.5. How fast is the top of the ladder moving? So we're trying to figure out dy dt. Y itself is just a horizontal distance. But when we start talking about y changing, the value of y changing, then we're talking about derivative. So it wants to know how fast the top of the ladder is moving down the wall when the base of the ladder is 3 meters from the wall. So they want to know what's dy dt when x equals 3. So all of these values they gave us are going to be plugged into our derivative because we have one of the derivative values and we want to find the other derivative value. So I'm just going to rewrite this as x squared plus y squared equals 64. And because they're talking about rates of change, we need to go through and differentiate with respect to t, because it's how quickly something is changing. Another indicator is because the units here are meters per second, where the lengths themselves are measured in meters, but then when they start saying meters per second, that's the derivative of our length with respect to time. So I'm going to go through and differentiate everything with respect to t here. And because neither of those variables that we see in the equation are t, they're going to be considered implicit derivatives, which means we're going to apply our normal derivative rules, but then also multiply by the derivative of that variable with respect to t. And then same thing on the y squared. The derivative for y squared is 2y, and then dy dt. And the derivative of 64 is 0 because it's just a constant. So let's look and see what we have. We have dx dt is 0.5, so we can plug that in. We have x is 3, so we can plug that in. We don't know y right now, and we're being asked to solve for dy dt. So right now, just based on everything we were given and doing the derivative and plugging in what we know, there's actually 2 unknowns in this equation. So what that tells me is I should be able to go back to my original equation and solve for that one value that we don't know. Remember, we're given x equals 3. So if we plug that in, we can figure out what the y value is at that exact same time. So this is 9 plus y squared equals 64. If we subtract the 9 over to the other side of the equation, we get y squared equals 55, which means y equals square root 55. So at the exact moment that x is equal to 3, y has to be radical 55 in order to maintain this right triangle shape. So we can go ahead and plug that in as well. So now the only thing we don't know is dy dt, and we can just solve for it using algebra. So I'm going to go ahead and multiply all those guys together. 2 times 3 is 6, and then 6 times 0.5 is 3. So I've got 3 plus 2 radical 55 dy dt equals 0. And then I'm going to subtract the 3 over to the other side of the equation, because now I'm just trying to get dy dt by itself. So we subtract the 3 over, and then we will divide the 2 radical 55 over. And this tells me that dy dt, which is the rate at which the top of the ladder is sliding down the wall, is negative 3 over 2 radical 55. And this is meters per second, because y is being measured in meters and time is being measured in seconds. If you want to change this to a decimal, you need to be really careful how you type this in your calculator, because we technically have a multiplication there in the denominator. So we would have to type this in as negative 3 divided by parentheses 2 radical 55. And when we do that, when I type that into my calculator, I'm getting negative 0.2 and then 0.226 approximately. So it just depends whether they're asking for an exact answer. For an exact answer, you'd leave it with the radical 55 in there, or the approximate answer. And then you could just go ahead and type that in the calculator and get the decimal equivalent. I hope that helps.